Hello students. Now we will look into the another financial application of LPP Financial Planning from the same book, right? It is on page 164. So the case goes like this. Hewitt Corporation established an early retirement program as part of its corporate restructuring. At close to the voluntary sign-up period, 68 employees had elected early retirement. Not all. Out of the total employees, 68 employees had elected early retirement. As a result of these early retirements, the company incurs following obligations over next year, 8 years. See, some people may be retiring in the immediate year, some people will retire after fourth year. Usually what happens is that when they reach a particular age, the agreement will say, okay, when you reach your say 50 years of age, you will take retirement, or 55 years of age, you will take retirement, right? So that is why these employees are getting retired over next 8 years, one after another. Few will retire in first year, few will retire in second year, and when they retire, the company need to pay them these dues which are there, and these dues are given here in thousands of dollars, right? In the first year, immediate year, $430,000, second year $210,000, and in the eighth year $255,000, right? And these are due to at the beginning of each year. So at the beginning, this money should be ready, with the company to give it to the employees. Now usually the legal system in most of the countries says like that. Once such scheme is there, the company needs to keep aside the money immediately, because see, tomorrow if the company goes bankrupt, then they will company may not have any money to pay them. So the legal requirement is that the company should either keep aside the entire money, or they should invest it in a such a way that there is no risk. So usually in government bonds you can invest, or you can keep it in fixed deposits. So the corporate treasurer must determine how much money must be set aside today to meet the 8-year financial obligations as they come due. So if you just add this, whatever amount comes, either that entire money is to be kept aside, or can you reduce it to from that total amount. So that is what the treasurer is trying to achieve. The financial plan for the retirement program includes investments in government bonds as well as savings accounts. The investment in government bonds are limited to three choices. So currently there are three bonds, government bonds are in the market, and these are the market prices of these three bonds. First bond is 1150, second is 1000, third is 1350. This is the rate of return you are going to get when you purchase these bonds, and the year of maturity. The first bond is going to mature in the fifth year, this is sixth year and seventh year. All these bonds have a par value of 1000. So even the first bonds, the actual value is $1000, but it is available currently in the market at 1150. And the last one is also $1000 par value, but it is currently available at a price of 1350, because it gives a higher rate of return, right? But this rate of return will be based on $1000 only, right? It will not be based on the market price, right? Now this means that even if the different prices each bond pays, and at the end of maturity the bond will be actually, the company has to pay back 1000. Company will get $1000 from government per bond. The rates shown are based on the par value. These rates are shown on the par value. For purpose of planning, the treasurer assumes that any funds not invested in bonds will be placed in savings and earn interest at an annual rate of 4%. So to begin with, we have to declare our variables. So let F be the total dollars currently you require to keep aside, right? for this entire thing. So F is the initial investment which you need to minimize. So that is why minimize F. B1, B2, B3 are the number of bonds you are purchasing for of this type, second type, third type. And SI will be the amount you are keeping it in the deposits with the bank at the end of ith year. So I will be 1 to 8. So if you look at this, first year 430,000 will have to be given to the people who are retiring in the first year, that you need to keep aside. Plus you will also require funds to buy these bonds. So to look at the first years, it will look like this. The equation will look like this. This is our objective function. Minimize F will be our objective function, and then subject to constraints are, first will be F, which is the total amount to be put aside or invested. All these are minus because you are going to invest. So 1.15 times B1. Why 1.15? Because 1150 is the market price, and you have to, this entire amount is in thousands of dollars, right? So that is why it is 1.15 times B1, right? They have clearly mentioned here their investments are expressed in the thousands of dollars. So that is why 1.15 B1 minus 1 times B2 minus 1.35 times B3 minus whatever you put in your savings account in the first year. So F minus whatever is this, the balance you need to pay to the people who are retiring in the first year, that is $430,000. So this is my equation for the first year. Now when you move to the second year, all these bonds will start paying you back. The B1 bond will pay you at an interest rate of 8.875. So that is why the first investment what you are going to get, return what you are going to get is 0.08875 times B1. B1 are the number of bonds you have purchased for the first type. 0.055 B2 plus 0.1175 B3 plus 1.04 S1. Why in 1.04 S1? Is that whatever savings you have put this S1, it will earn 4% interest. So that will be 0.04 times S1. But at the end of every year, your bank will return you the entire amount. It will go to your account. So that is why you will get 1.04 S1, right? Minus, if you want to invest something, see, this bond purchasing will happen only in the beginning. Afterwards you will just be, if the money is there, you will put it in the bank account. So minus S2 is equal to 210. Why 210? Because we have to pay 210,000 to people who are retiring in the second year. So this is how your second year equation will be. Third year equation will be similar to this. Fourth year, but only this one will be equal to 222. Here this one will be equal to 231, but this will be equal to 240. Now at the end of fifth year, the first bond will get mature. You see here maturity is 5. So in the sixth year you will get the interest of that bond as well as the entire amount you will get it back. That is why you will get 1.08875 B1 plus the remaining are still giving you interest, plus all this remains the same, equal to 195. In the next year the second bond will mature, so you will get this, and first bond will not give you any returns because it is matured. You have already collected the entire money from that bond. And the eighth year will be this 1.1175 B3. So this is going to be your model. So your entire model is looking like this. This is your objective function. Then this is your first year. This is your second year equation. Third year, fourth year, fifth year, sixth year, seventh year, eighth year. Plus you will also write that all these variables B1, B2, B3 and SI, S1 to S8 should be greater than equal to 0, which is non-negativity constraint. So then when you run this, when you set up this model in Excel solver and run it, you are going to get this amount. So if you see, you are going to get 1728, which will be definitely less than the total of this. You can try it out, you can see what is your savings. So when you add this, you will get a higher amount than 1728, which is your final answer. And you are going to purchase 144 B1 type bonds, 187 B2 type bonds, 228 B3 type bonds, and these are the amounts you are going to multiplied by 1000. You will put it in the banks. So this is your financial planning problem. Thank you.